Yeah, because on that one, I didn't even do it on the answer key. I said we do it in class, so that's a good thing. So, what do you say, 11-2?
11-6, like one of those, like number 25.
Yeah, okay. So, when it's in this form, tell me everything you can tell me about this. Not left or right. That would be x equals y squared. That'd be horrible. We're only doing up and down. You with me? Y equals x squared looks like this. X equals y squared will look like this. We don't do left and right yet. You guys do that in pre-calc if you take it. We have a parabola opening that way or that way. If A is positive, it opens up. If A is negative, it opens down. What's the vertex? What's the vertex? Man, you guys are going to suck on that problem. What's the vertex? So two things. It's not negative h because it's like related to how it transforms, right? And a vertex is a point. So if you're telling me one thing, it's bad. A point has at least two parts. So what's the vertex? No. HK, yeah. Right? I think we did a lot of. So like if I said x minus 1 squared plus 2, what's the vertex? 1, 2. Okay. All right. So those are things you know. So on this problem looks like this. It seems to be missing something, but it isn't really missing something. So tell me, is it opening up or down? Up, because it's positive, right? What seems to be missing, but it really just means there's a certain number there? Seems like K is missing, but that means there's a what here? There's a 0 there. So the vertex is something 0. What's something? No. Negative 1. Because it's the opposite of the sign of this, right? Which way would this move? Would it move it left or right? Would it move it that way or that way? Forward or back? It would move it back. Why? Because everything I plug in is allowed to be 1 less than it used to be. Because the first thing I do to it is add 1. So how do I get a 0 out of this? What do you put in there? Negative 1. So there you go. It moves back 1. Compared to this, how do I get a 0 out of this? I put a 0 in. How do I get a 0 out of this? I put a negative. Everything moves back 1. So when it's in with the letter, it's the opposite of what it looks like. When it's out here, it's exactly what it looks like. Yes, ma'am?
What about that minus b over 2ac?
Let's not do that yet. I'm not done with this one. We'll do a problem like that in a minute. This isn't in the form to use that because it's not in a squared plus bx plus c form, right? That's a shortcut for when it's in that form. This is in the vertex form. I can see the vertex. Now, how many more points do I need to be able to graph this parabola? How many more do I need to calculate? 1. Because what the hell can I do after that one? Here, what's the y-intercept? How do you find the y-intercept always? You make x 0. Don't forget that. That never changes. I don't care what level of math you're in. How do you find the whatever intercept? You make all the other letters 0. We only have 2 letters here, thank God. So when you make x 0, what do you get? 1. So if I plot this, negative 1, 0, 0, 1. Can anyone tell me where there's another point? Here's the vertex. Here's the y-intercept. Where is there another point? Where's the axis of symmetry? Yeah, here's the axis of symmetry, right? There's a point there. Where's there another point?
2, 1.
Negative 2, 1. Yeah, the mirror image point, right? So you really only ever need to get the y-intercept and the vertex, because then you automatically got another point. It's the mirror image point. That kicks so much ass. Whatever form it's in, you find the vertex, the y-intercept, you automatically got a third point, the mirror image. Why do I only need 3 points? Because you guys know what it looks like. The more you know the shape, the less points you need. So now I just fill in the shape. Yeehaw. Make whatever sound effect you want. So here, you guys do this one. Graph this. I'm gonna be that guy at the movie theater. What's the vertex? 2, negative 1. 11. Uh-oh. What's the y-intercept? 0. Let's see.
4.
You make x 0, what do you get? Negative 2 squared is? Minus 1. Work it out. You make x 0, and then you see what you get when you make x 0. That's what it means to make x 0. You plug it in. You do it. What do you get? 4 minus 1, 3. So then I've got 2 points so far. So I got 2, negative 1, 0, 3. Does it open up or down?
It opens up.
Thankfully it opens up, because it's supposed to go up to here. If you thought it opened down, you'd be like, oh shit, I'm never going to get up there. That's a problem. So you got checks and balances. Where's there another point? Yeah, 4, 3, 11. So it's 1, 2, 1, 2. Mirror image point, right? Through the looking glass. Wow. How would you find that guy's x-intercepts?
Make y 0.
Yes, make y 0. Where's y?
G of x.
Yes, make this 0. Figure out the x-intercepts. Solve that. Never forget that. It's that simple. I want the x-intercept, I'll make y 0. I want the y-intercept, I'll make x 0. And see what happens. Bless you. But never change. Bless you. Never changes. One of the last math courses I took, I had 17 variables in a problem. How did I find the w-intercept? I made all the other letters 0. That's how I did it. That's how you do it forever. Freaky. Don't worry about it. We're not going to have 17 variables.
By the way, they dropped it in your mailbox.
Oh, good.
Yeah.
Just now?
I told them. Yeah.
Well, that's funny. You shouldn't have to call and tell them.
Lazy people.
Aw. So how do you solve that? Yeah, add 1. Okay, that's a good start. Square square root. Yes, right? Kill the stupid square. Why is my x part stuck? Stupid square. All right, don't FOIL that shit out. We just directly kill the square. When I do this, what do I put? Plus or minus. Thank you. I always get people leave the square root on the one. Square root of 1 is 1. So you don't need the square root. Just do it and get what it is. And now I've got two numbers. I get 1 is x minus 2, so x is 3. Or negative 1 equals x minus 2, so x is 1. Look at this. Look at that shit. I almost got it. Got pretty close. Didn't even know what they were. I got pretty close. Do you guys see that? That's where it hits the x-axis. So that never, ever changes. How you find the blank intercept. You make the other variable 0 to find it. Never forget that. It's just all you gotta do. Okay, how's that? Is that all right for that? You want to do another problem like that, or you want to do something else? It's up to you guys.
Yeah, can we do another problem?
Sure. How about we do one where you got to put it in the standard form? And then we'll double check with the negative b over 2a thing. I don't expect you guys to go, yeah! Sounds fantastic, Jeff! All right, let's see. Yeah. Okay. Let's see what happens. Oh, shit. So now the instructions here would say, put this into vertex form, or whatever the hell that is. Ax minus h squared plus k. That's vertex form. So what do I have to use to do that? So I want to put it into this form. Got it.
Is that a K? What's inside that?
No, it's an H. You know this. Where's the A coming from? Ah, so take a negative 2 out, right? Because what I have to use to make this look like this, probably want to give it what it's missing so that I can write it as a square. So I probably want to complete it so I can have it complete the square. Right, so if I take a negative 2 out, yeah, the minus 1 over. How do I complete the square in here? What's the 2 steps for complete a square? I know you know.
Well, you divide.
Cut the sucker in half
And then
and then square it. So where's the 4 go?
right next to the negative 4x. Which is plus.
So what did I actually just do? I mean, I put the plus 4 there. What did I actually just put? Negative 8. So I better do what out here? Plus 8. I just took something away. I better add something. So overall, I did nothing. So where's the part that I added? I added this and this, right? Well, negative 8 plus 8 would bring me back to this. I mean, so it's the same thing. All right. If you do your homework, then you would know what I'm talking about. Then what's this become? Good. X minus 2 squared. And what do I have out here now? So what's the vertex? 2, 7. I like it. Does it open up or down?
Down.
Down. And what's the y-intercept? It's a really easy way to get it. Trying to hammer it in your head. Anytime you tell me an intercept, it's a point. You're going to give me a full point. Try to graph that. So vertex is at 2, 7. Y-intercept is 0, -1, which makes sense because it's supposed to open down. So this is good so far. Where's there a third point?
4.
Yeah. It's got to be equidistant, so it's going to be 4, -1. And then you just connect. Wee-haw. There's your... What's the equation of the axis of symmetry? Okay, I'll answer that question. X equals 2. It's a vertical line, so it's x equals. How can you, what's the one point that we didn't calculate? That 4 with -1, right? So what's a nice way to kind of check to make sure you're on the right track? Well, if you plug a 4 in, you better get a -1 out, right? That's what that says. That point there says input 4, output -1. I didn't get that from calculations. I got that from an idea, the mirror image. So if my idea is correct, when I plug a 4 in here, I better get freaking -1. So I get -2 times 4 squared is 16, plus 8 times 4. Well, that's -32 plus 32. That's 0. Minus 1 is -1. Oh, shit. Yeah. So you can check your work. You can take a point, you kind of got a different way, plug it in and see if it works. That tells you, yes, that is true. Yeah.
Can we go over some of the final?
Yeah, of course. Like any part I want to, or
One, like, I feel like I've done some already. Like, 1 each.
let's see if I brought it to. Yeah, sweet. I have one copy. Oh, do I have more? Yes. Anybody else need a copy of that practice final? Sorry, which one?
1 each.
1E. Oh yeah, all right. So this is, I could describe this as a sneaky way that math teachers put 4 problems into one. In this case, it's really 3 problems. Because what do you do to start simplifying this? Can I just go, there's a 5, let me kill a 5, let me kill the x cubed. Yeah. Notice I didn't actually do this. Probably not. Why not?
Simplify everything.
Or GSF?
Huh?
GSF.
Why do I have to do that? Why can't I just kill the x cubes? Look, they're the same with the shit. With these x cubes, why can't I just kill those? Yeah. Why not?
Because it's like a problem, like they're adding.
Okay, good. I can't break into addition with division. That's not what division does. Division can't break into an addition problem. Right? If I had x plus 7s in here and I wanted to get rid of the 7, I'm not going to send division in. I'm going to send subtraction in, right? So I can't cancel part of an addition and subtraction problem with division. So what am I going to do then? What does division kill? Multiplication. So if I factor all this shit, then maybe parts of them will die, because division will kill parts of multiplication all day long. That's what it's defined to do. That's what it was created to do, right? Sorry. All of math is a really weird action movie for me. So you just start factoring like crazy, right? What did I say about a trinomial, but you have a cube in the problem? What should you do first? You should do the cube first, because sometimes that trinomial will actually be the big dude, which is not factorable. So I have people sit there and stare at this for 10 minutes. I'm like, stop staring. What's the only thing you do with this?
Take an X out.
Take an x out. The rest of it's not factorable, because it is going to be this big dude. You can't factor the big dude. You're going to go slightly more insane if you try to. So here I'm going to do like he said. Take an x out. What can I do on this? Take 5 out. What am I left with?
X squared minus 9.
How do I factor this guy? Good?
X.
X squared.
Is it plus
3.
negative 3?
Negative
Minus 3. What goes at the end then?
Positive 9.
Good. And the middle's going to be,
3.
what's the sign? See?
What was your acronym for that? So?
So, yeah. Same sign. See, same, where'd it go? Same sign. Opposite sign. Always positive. Again, I really dislike most acronyms. And students, when they hear me say that, they hear me say, I don't want to make math easy for you. Well, that's not what I'm saying. Why is this always positive? Because this is what makes the sign what it's supposed to be. If it was negative, it would change it to plus. Well, of course it's always positive. But if you want to make it part of a little acronym, sure. Just see why it makes sense. Why is this the opposite sign of this? Because who's this guy? It's the hose. He's a cleanup dude, remember? He's the one that kills all the extra shit that I don't want. No? Did anybody watch Pulp Fiction after talking about it? You haven't seen it yet? I don't know. You might not like it. And now you just go to 10. Everything's, well, I gotta finish this guy out, right? But, I mean, can you see how this is going to go? This guy dies. This is going to be x plus 3, x minus 3, right? So part of it's going to die here. The 5s die. You can kill some x's. That's the idea of that problem. Factor, 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 kill, 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 kill. Right? The factoring step is making it become multiplication so the division can actually do something.
I got that part, and now I just, how do you like solve the rest of it? Like that's the part that I already got, and I just needed to like.
So the 5s die. One of these x's dies, right? This becomes x plus 3, x minus 3. Is that cool?
Yeah.
So this dies. So let's see what's left on top. Just an x plus 3, right?
Right.
And what's left alive on the bottom?
X cubed.
Square.
One of the x's killed.
Oh yeah, squared.
Yeah. So you do want to try to be nice to yourself. Make it easy to see what's left alive, so you don't leave anybody behind.
How did that X die, the one on the top right? Yep. Oh.
There were 3 down here, so that's why there's only 2 left down there. Yeah. Cool. I like it. And that's another reason why, if you have stuff, don't multiply it back together at the end. You want to write it all down, and you want to be able to see if anything else still cancels. Don't distribute, don't FOIL at the end of one of these problems. Leave everything separate so you can see if you forgot anything. Yeah.
1G.
1G? Oh, okay. So it's kind of related to this. Okay. It's only related because it involves doing what first? Factoring. Again, it's the same idea. So I can see what things are made of, right? So, how do I factor this dude?
X plus 5, x minus 2.
Yeah, I'll bet you anything it's got to have that in it. It's always a nice clue. So who's missing what?
Minus 2.
Yeah, the second dude is missing an x minus 2. So now, here's a big mistake. I'm trying to get it so you guys wouldn't do this. I see so many people doing this. Well, there's a lot of other mistakes too, but... And then you cancel it. Cancel. I don't know what. You can't cancel these. Why? This is involved in a subtraction problem. You can't break into a subtraction problem. That's why I try to get you guys to distribute before you wrote it down here, because your brain looks and says, "Ah, sweet, get rid of shit," right? But then it's basically, if you kill those, it's like you're saying, "I didn't have to do this," because they just immediately went away, and that's silly. Of course I had to do that. It has to do something to the problem. You can't just go, "I'm done." Whee! No. So I try to get you guys to avoid that issue by working the distribution up here. Negative 2x plus 4. See, now your brain can't even see that to try to do it. So yeah, you could write this all down here, and yeah, that would maybe make the negative easier to remember, but then you would be open to making that stupid mistake there. So as a teacher, it's kind of like, well, which way do I show? What's going to make them do things better overall? And I just got one more thing to do. So don't multiply things out in these problems. You don't need to. And you can see that nothing else cancels. Yeah.
So the bottom x plus 5x minus 2, since both sides are the same, that's why I say the same on the bottom.
All right. Now, every fraction you've ever worked with, and when you're adding them, the bottoms had to be the same, but when you add them, what happens to the bottom? It stays the same. Why? Because you got 3 of these plus 2 of these is 5 of these. If you put 5 16ths, I'm like, where did you get any 16ths? I don't see any. So I got 3x of these plus negative blah blah of these. I got so many of these. The bottom stays the same. You're collecting those. Yeah. Anything that numbers do, those have to do also, because variables are numbers. Yeah.
Can we do D?
So what do you have to do first on 1D? What's a really good... There's 2 kind of things that I could take as a first thing to do. Flip the negatives. I love it. Only the negative power thing. So would I flip the 24 down with the x? 6x's? No, because the 24 is not being raised to a negative power. And what's the other thing you can do with the numbers?
Bring that negative up.
Okay, you can flip the negative powers. What can you do with the numbers? Yeah, so let's flip the negatives first. So those 6x's go down with these 7x's. So they came down. And up top there were 7 y's, and then 7 more y's come up. So these guys went down, these guys went up. Do you guys see that? Negative power means flip. Now I always get somebody telling me the answer to this is 9. I'm like, that's different. 24 divided by 15 ain't 9, right? And why do people think that? Because when you divide things with powers, you subtract the powers. Are these powers? No, they're just freaking numbers. They're going to act like they always have. They're not powers. They don't act differently. They're just numbers. So what goes into both? 3. So you get 8. 5. How many y's you got on top? How many x's on the bottom? Done. So if you flip all the negative powers, there's no negative mistakes to make because you got rid of all the negatives. There's many other ways to do that problem, but I suggest you do that. Get the negatives out. Because what's one of the main things you make mistakes with? Negatives and 0, right? Poor little 0. Oh yeah, good, okay. Thank you. You gotta remind me. Alright, here we go. Alright, so how do I write, so this is number 7. How do I write that as a matrix?
You got just the numbers?
Who to what?
You got just the numbers?
So be specific.
3, negative 1, negative 5, and the line, negative 7. Negative 1, negative 2, 2, 8,
sweet. And then you always double check at least, right? Because you don't want to start doing shit with this when that's supposed to be a positive one, because then you're dead. You don't have a chance. So double, triple check when you write down the matrix. That's the first thing I look for. I can't get this to work. Oh, well, it's supposed to be -4. So some of you guys who've asked me the question, you've lived that. Now, with that said, on the test, if I were you, I don't care where I put this problem, I'm doing it last. And it's so easy to make a simple mistake. I'm going to grade it the same way I did before. If you show me enough evidence that you know the steps to take, you will lose less points if you can't finish it. If you do something illegal, then you're going to lose a lot of points, obviously. But if you know what you're doing and you make some silly mistake and it's not coming out right, don't erase everything. Leave it. And then take another piece of paper, try it again, and then your best attempt, maybe. Turn that in, right? So it does not take much to completely screw this up. Because we're human. We're going to have a negative in the wrong place. We're going to add 8 plus 2 and get 16. We just are. Right? That's what we humans do. But if I can see you know what to do, you know the steps to take, you know what you're not allowed to do. You're not allowed to multiply 2 rows together, my God. Of course you're not. That doesn't make any damn sense. Right? What's 3x times -x? Negative 3x squared. Do you have anywhere in here for x squares? No. So you can't do that shit. So what do I do? What do I do?
Would you multiply like row 2 by 3 and then add 1 and 2 together?
So you pick a column to start with, right? And actually any column, they all have some kind of 1 in them, so any column would do. The way I taught you was to start with the first column, but now you should realize you could do any column you want to. This column has a 1 in it. In fact, it's nice it has a -1 in it, so I don't have to change the signs. It's already opposite signs. And sure enough, if I multiply row 2 by 3 and add it to row 1 and put the answer where?
At the top.
Yeah, put the answer here. Now, some of you guys might say, why would I do that? I want a 1 here. That's not a 1. That's my 1. I can flip these rows, right? I'm not going to do that yet. Okay. So I got my instructions. If you write something like this down for me, it'll be much easier to grade. And if it's easier to grade, you have a much higher probability of getting partial credit. So as you do this, tell me what the shit you're doing, right? So right here I can write 3 times row 2, so that'll be -3.
-6.
-6. 6. 24. And now I can add, so let's see. -3 plus 3, 0. -6 minus 1, -7. 6 minus 5, 1. 24 minus 7, now can we handle, so I'm done with these, right? Get it. Okay. How do I kill this guy?
Multiply the second row by 5.
Yeah, so if I take 5 row 2 plus row 3, put the answer in row 3, because I don't want to lose my 1. How you guys doing? Does this sound familiar? Mm-hmm. So now I can put down here, what do I get? -5, -10, because what am I doing in row 2? Multiplying 5, 10, 40. -5 and 5 is 0. -10 minus 2 is -12. 10 minus 1 is 9. 40 plus 11, 51. And then I got -1, -2, 2, 8, just sitting there. So if you want to right now, to make it, does the first column look right? No. Something's in the wrong place. And it's negative, right? So I could switch these rows and multiply this row by a negative. And then it looks closer to my goal, right? What's my goal? To not go crazy. 1, 0, 0, 0, 1, 0, 0, 0, 1. Number. That's my goal, right? So I can switch these rows, and then I can divide this by -1. Right, eventually, you don't have to do it now, but I'll do it now. So I get 1, 2, -2, -8, 0, -7, 1, 17, 0, -12, 9, 51. Now, can somebody tell me what is a good column? Because I'm done with the first column, right? It's exactly what I want it to be. Mwah. What's a good next column to do?
3.
Why the third column is the best?
It has the 1.
It has a freaking 1. I like it. Now, it would suck if that 1 was there, because I couldn't use it to kill this, because then the 1 would make the 0 go away. And what do you definitely never want to lose? Zeros. You worked hard to get them. You don't want to lose them. Right? So if I take this, how do I kill this? You take row 2 and multiply by 2. Add it to row 1. Put the answer where?
Row 1.
Row 1, because that's where I want my 0 to show up. Right? And again, I know the 1 is going to be in the wrong place, but guess what I can do? Look what I can do. I can switch the rows again. Not a big deal. Right? You guys with me? If the 1's not quite in the right place, you can just switch the rows. Not a big deal. That's equivalent to writing the equations in a different order. So that's why it's completely legal. So let's see. If I do double row 2, so I get 0, -14, 2, 34. And if I add that to row 1, I get 0 and 1. Didn't screw with my 1. -14 plus 2, -12. 2 minus 2 is 0 like I wanted. 34 minus 8, 26. Now the same thing as before. Can we do this again? What do I multiply row 2 by to kill this guy? -9. Cool. So you can do -9 row 2 plus row 3. Put the answer in row 3. So I get 0. -9 times 0 is 0. -9 times -7 is 63. -9 times 1 is -9. -9 times 17, I don't know what shit that is. 153? Yeah. -153. Nobody's going to help you, Jeff. I know, Jeff. Okay. And now if I add these together, 0 and 0 is 0. 63 minus 12, 51. -9 and 9 is 0. -153 and 51 is -102. What's nice about these? Yeah, 51 goes into -102. Because what do I want here? I want a 1 there. And then I can just flip it with the other dude. So let's rewrite the middle guy. So again, what's kind of in the wrong place? In that last column we just did that, that's in the wrong place. I can just switch these around, right? And I can divide this by 51. So if I divide this row by 51, so I get a 1 here, and I flip these rows, let's see what we get. So the first row is just sitting there waiting. This row goes here. And then this row goes here, divided by 51. That'll be -2 there. And I remember this feeling when I first learned this, is when you get that row and it comes out nice to a nice number, you're like, oh, okay, okay. It's better than getting 11 over 89 here. So I'm like, oh shit. I'm not going to give you a matrix that's got funky ass fractional answers. So if you're getting them, you're doing something wrong. And then how would I finish this up? What's the last column to work on? The middle one. So that 1 can kill that 1 can kill that, yay, right? Okay. So I mean, just to finish it out, I'm going to not write much. I would multiply by 12, so this would be 1, 0, 0, -24 and 26 is 2. Multiply by 7, 7 and minus 7 is 0, 0 plus 1 is 1, -14 plus 17 is 3, so it looks like that's the answer there. So what's the process? Find a 1, make zeros. Find a 1, make zeros. Find a 1, make zeros. So remember when we first learned these. Now, I know you guys don't love these, but are they better than they were the first day we looked at them? Do you understand that they make it into more of a game? Really, they do, right? I like amazing. Sure, whatever, man. All right. So I think that's the only one I didn't put on the answer key. Let me go ahead and give you guys the answer key before I forget. There's 2 parts to it. Let me do it one at a time.
Is there a final about like this many?
I don't know. How many problems are on you? Final exam for me normally is about 20 something, 25, 26. That's some problems. Counting like A, B, C, D. Right?
Oh, we really got one.
No, this is the second page. Oh, we'll do one more back there. Take this.
Can you go over how to solve the piece of the cube real quick? I don't remember how to do that. Also, I don't remember. So,
So what's that? What's the question? Sorry.
can you just real quick run through how to do difference of cubes?
Oh yeah.
I've never heard of that self-matching thing, so
Oh, you missed that day.
I probably did. Almost half this class.
Because anyway, I taught you guys that SOAP thing, even though I don't 100% agree with teaching that. But oh well, I did it. So yeah, if I had 8w cubed minus, what you got, 125 m cubed. Yeah. So no GCF. There's 2 terms. It could only be squares or cubes. Very obviously it's cubes because that's what he asked for, and there's freaking cubes. I like it. So what do you, when you put down immediately? No. I mean, little dude, big dude. I like it. And then if you break this up into 3 parts, you do get 2w, 2w, 2w. What about this other guy? 5m. Yeah, 5m, 5m, 5m. So the little dude goes 2w. Good.
5m. 4w squared.
Always positive. Plus 10 MW or WM, doesn't really matter. This guy looks like he wants to factor, right? He don't. Never. Ever, ever, ever. Never. If that was twice as big, it would factor. The middle's always half what it needs to be.
Where did the 10 MW come from?
2W times 5n. The middle is always those 2 multiplied. I actually showed you, we broke it down as to what if we don't put that there, we get too much shit. We get more than just this and this, so it can't be right. Putting that there eliminates the extra stuff we didn't want. It's my own thing to talk about Pulp Fiction there. It's not a generally accepted way to do that, but when I first thought of it, I'm like, oh my god, it's perfect. Clean up dude.
Can we do,
The wolf, that's right.
can we do 2A, B?
Okay. So 2A, what's a good first step for that word problem? Besides run away screaming. Draw a picture, I like it. So, triangle. One side is 3 less than twice the smallest. The largest side is blah, blah, the smallest. So which side do I have to call just a variable? Which side do the other two depend on? Smallest. So I have to give him a name first. If the other two are built off the smallest, I have to give the smallest a name first. And then I can give everybody else names based on that. This, right? So one of the most important steps in word problem is who is just X, or whatever letter you want to use. So I got smallest. What else do I got? Smallest.
And 3 less, twice the small.
No. One name of a side is smallest. What's another name of a side?
Largest.
Largest. What's another name? I love this
3
one.
times this one?
1.
Is it 1?
Look, what's it say? It's the first word. One side of it. Okay, that's one side. A one side. So the smallest is X, so there's X. What's it say for the one side? 3, like you guys are trying to tell me over. 3 less than twice. So how do I write that? 3 less than twice this. It's what did I do wrong? What have I done wrong?
The 3 is on the wrong side.
Yeah. Again, that's English grammar. It's not math. Gather. That's my poor writing skills. 3 less than twice the smallest. And the largest is,
3x plus 5.
yeah, 5 more than 3 times. So 3 times increased by 5. So just to kind of, here's my largest, here's my one side. Just have a visual if you want. And what's it say about this triangle?
Find all the sides.
The perimeter is 62.
Perimeter is 62. So what equation do I get from that? How do I find the perimeter of anything?
Addition.
You add up all the sides. So now you just make sure you get all the sides. There's that side. I also need that side. And I also need that side. The biggest mistake I see is people forget that guy. Because you can see 5 more than 3. You can see 3 less than 2. And then you forget there's a freaking X that gets everything started. If you list them, you're not going to forget them. And that equals, what was it, 62? And now should be the easy step. I just solved that sucker.
And then you
Yep, and then you can figure out what X is, so then you figure out what these are. I like it. Make sure you answer all of them. Make sure you put units on them. You won't see it, but I'll still write shoes or something stupid. 10 shoes? 10 light years?
Number 10, could you show me how to graph?
Oh, this is almost exactly like that one we did earlier. I said an 8 in the middle instead of a 6. Man, this thing really sucks. So number 10 is the vertex problem. So it says, find the vertex. Oh, good. I forgot about doing that earlier. Does it say anything about putting it into any kind of certain form?
No.
If it doesn't, don't do. Holy shit. That's gross, isn't it? It's kind of gross. You still have to be able to do it. But if I don't have to, I don't want to. What's the shortcut to find the vertex? Yes.
Or 2
I like it. So that's the X piece. I like it.
That's for the vertex, is it?
Yep. So what's B? So negative 6 over twice. What's A? Negative 2. I like it. So you get 6 over 4. Negative 4. Which is?
3 over 2.
Yes, negative 3 halves. I like it. How did I find the Y piece then? If you know X, how do you find Y?
Or you plug it in.
Plug it in. Go ahead. If you want to. You already get the answer. I know some of you guys don't want to, but oh well. You got to be able to work with fractions to be able to get anywhere. So you're just going to plug a negative 3 halves in. basically get 10 minus 9 halves. So you get 20 over 2 minus 9 over 2 is 11 over 2. Come to 2. Is that what past Jeff got? Really? All right, sweet. I hate it when past Jeff gets wrong things. Past Jeff. I hate that guy. So what did I just do? What did I just do? I mean, overall, what did I just do? Here, math. Good, I like it. Now be a little more specific.
Found the vertex.
Found the vertex. What's the vertex?
-3 over 2, 11, 2.
And to be a little bit easier to graph, because you're going to have to graph this sucker by hand, this is -1.5, and this is
5
5
and 1.
and a half. So you can find those a little easier now, right? You can find the halfway points easy enough. If I made you graph 7